In this example, we want to create a function where our new interface will be our input variable inside of our function. Inside of sector, we will put our machine structure as embedded type. We want to create a new function, notify, which will be connected to our sector structure. We want to add abstraction to our notify function. We will write new interface where we will put new method which will have the same pattern as our notify function. Now we give abstraction to our notify function, which is connected to our sector structure. In previous example, we saw how we can create interface and how we can transform interface into another structure. In that way, we gave abstraction to our structures. Let's see what if we put our interface as input variable inside of our function. For this case, we will write new function send notification. Here alias for our new variable will be n, and data type of this input variable will be notify service, which is our interface. So now, when we open the block, we want to write new implementation. First, we will access our n input variable, and then we will call specific method from our interface. What exactly we achieved with this implementation? Well, now for our input variable on place for alias n, we are expecting all structures which can be transformed to our notify interface. We will again, like in previous example, check all conditions which we must apply for our interface, and then we will see the list of structures which we can assign to our specific interface. So in this case, for our n input variable, we can pass new sector structure because our notify interface can be transformed into sector structure. How we can check that? Well, in our notify service, which is our interface, we have a notify method, and that method has exactly the same pattern as our notify function, which is connected to our sector structure. In final picture, this means that if we pass new sector structure as our input variable inside of our send notification function, execution will look like this. When we execute n.notify, actually our language will transform our n interface into our sector structure, and then that sector structure will call notify implementation, which is connected to that specific structure. So let's now write practical example of this implementation inside of our main function. We created new variable s1 as data type sector with pointer. We want to create new variable ns, which will have data type of notify service. Now we want to transform our ns variable into our s1 variable, which is sector with pointer. We want to call notify method from our ns interface. When we call our notify method, we can see for our output implementation of notify function for our s1 variable. But now we want to call our send notification function, and we want to pass our s1 variable to that function as input variable. In this case, we passed s1 variable to our send notification function, and output, as we can see, is exactly the same like output when we call our notify method from our ns interface. In this case, we learned how we can transform interface to specific structure when we have interface for our input variable. We need to remember one important thing. In our send notification function, when we wrote interface as our new input variable, on that place we are expecting only structures which can be assigned to that specific interface. In this case, only sector structure can be assigned to our NS interface, because in this case, NS interface can be only transformed to our sector structure. In case when we want to pass specific object which has data type sector but without pointer, we must pass that variable like this. In this case, when we pass s2 variable to our send notification function, we must write ampersand sign in front of our s2 variable, because this variable doesn't have pointer, so we must pass specific location of that object. In first case, we passed only s1 variable to our send notification function, because in that case we passed pointer, which is already location of that object. Let's now write interface where our method inside of our interface will have multiple implementations. We want to create two new functions with same declaration and same pattern, where first function will be connected to our user structure and second function will be connected to our company structure. We have two different functions connected to two different structures with same name and with same pattern. So in this case, we can create abstraction for these two functions. We will write new interface where we will put new method which will be matched to our functions. We have a new interface, name service, and inside of that interface we have one method, setName, where this method has one input variable as string and doesn't have the output. So this method inside of our interface has exactly the same pattern as our two functions, which are connected to our user and company structure. Let's now create function where we will put our interface name service as our input variable. We created a new function, method setName, where we have two input variables. First variable, m, will have data type of a name service, which is our interface. Second variable will be value, which we want to pass to our setName method. We have totally different implementation, because now our name service as our interface can be transformed to user or to company structure. Now when we pass new object for first input variable inside of our method setName function, that object can have data type of user or company. So now what is the difference in our implementation? If we pass user structure to our first input variable, then execution of our m.setName function will be that our m interface will be transformed to our user structure, and then that user structure will call setName function with name variable, which is our second input variable inside of our method setName function. In second case, if we pass company structure to our first input variable, then our m input variable will be transformed to company structure, and then that company structure will call setName also with name variable, which is our second input variable. So in this case, we have one implementation with one interface, but we have two cases and we have potentially two different outputs, because at this point we don't know which object with which data type will be passed to our first input variable inside of our method setName function. So let's now create practical example for both cases inside of our main function. Now we want to call two times our method setName function, where in first call we will pass our u variable and in second call we will pass our c variable. So now we called one specific function in one specific implementation, but we passed for first input variable two different objects with two different data types. Because for first place inside of our function, we are expecting all possible structures where we can transform our interface from input variable to that specific structures. In this case, we can transform our input interface to both of these structures. So now, when we print our objects U and C, output will look like this. We can see that our objects has new values inside of them. In final picture, we changed values of our objects with only one function. In the next video, we will see how we can write multiple interfaces and what if we have case where our structure can be assigned to multiple interfaces.